The U.S. Treasury Department reports that $1 bill is 6.14 inches wide and 2.610 inches tall. One U.S. quarter is a circular metal coin with diameter equal to 0.955 inches, and we're supposed to answer a bunch of questions. We're going to use this as an excuse to remind ourselves the rules for sig figs. So what is the area of $1? Well, we're given some measurements, and so we can begin writing down the area of the dollar as the width times the height, and so we can write 6.14 inches times 2.610 inches. When we do that multiplication, we find that this is 16.025 and some more digits that I'll leave off, and this is inches squared because it's an area. Now, should we report all of those digits? In other words, do we trust them enough to circle that as our final answer? The answer is no, and we can demonstrate that by considering an alternative scenario in which we knew the width of the dollar a little bit better. So, for example, let's imagine that the width was, instead of 6.14 inches, it was measured a little bit more precisely to be 6.144 inches. So, for example, imagine this scenario where you have a slightly better measurement of the width and you compute the area of the dollar to be 6.144 inches times 2.610 inches. What you'd find is 16.036 and some extra digits inches squared. This is pointing out to us that the numbers that we use to make this computation are not precisely known. There's some inherent uncertainty in there. And just by exploring what would happen if we knew one of those numbers just a little bit better, we see that we get a different number. There is agreement, partially, up to the first decimal place. And so it seems that we can at least trust our result to that level of accuracy. And so the final answer that I'm going to give here is 16.0 inches squared. So we have to remember that while we do our calculation, we can keep extra digits around, but in the end, what we're going to report for our final answer is limited by the limitations of the inputs. We can summarize it this way. Whenever you're multiplying or dividing, the so-called limiting term, the input that is going to limit the amount of digits you can report in your final answer, the limiting term is the number with the least number of significant figures. If you notice, given the problem we're doing here, this has 3 significant figures, whereas this one has 4 significant figures. Therefore, we are limited in our final result to 3 significant figures. The answer should have the same number of sig figs as the limiting term. That said, we can now compute the area of 1/4. Let's do that in red. Keep in mind that a quarter is basically a circle, and so when I write the area of the quarter, I need to use that formula, pi r squared. As I work through this computation, I've got pi, which is a number that can be calculated to any desired accuracy. The radius is half the diameter, so I would put here 0.955 inches divided by 2, and I will square that quantity. You might be using a calculator, in which case these details are less important, but if you're doing this by hand, notice what happens. This is pi, and half of 0.955 gives you 0.4775 inches, and that needs to be squared. I do not want to round yet. I want to keep extra digits around, maybe 1 or 2 extra digits, and in the end is when we will use our rules for sig figs. When you work this out, this comes out to be 0.716, and then there's a 3 and a 0 and some extra digits that could be calculated. That's inches squared. Notice that we only should be trusting this final result to 3 sig figs because our input had 3 sig figs. And so in the end, what I'll do is I'll round this to 3 sig figs, in other words, 0.716 inches squared, using the rules for significant figures. Again, keep around extra digits while you do your computation, only round at the end. Okay, What is the combined area of 50 $1 bills? If you recall, we did this computation where as an intermediate result we found this area and then we rounded. For this problem, we need to compute the area of 50 of these things. In other words, the area that we want is 50 times the area of a single dollar. Well, if we write everything out, this is 50, and then the area of a dollar, what I'm going to use is the unrounded quantity. Again, it's very important to use unrounded quantities which contain a little bit of extra information, and only at the end do we round. Now, as I stare at this computation, you see the number 50 looks like it has only 2 sig figs, and on some level that's correct. But when you're counting things, almost always we assume that the uncertainty is 0. We know that there are exactly 50 single dollar bills here, so this is exact. This is trusted to 3 sig figs, and so what I should do is do this multiplication and then round to 3 sig figs at the end. When you work this out, this is 801.25 inches squared. And so to get my final answer, I will round this to 801 inches squared. Notice that if I didn't do this intermediate value stuff and I instead started with 16, I would get 800 inches squared, and that would be slightly less correct than 801. Okay, finally, what is the area of $1 with the shape of 1/4 cut out? In other words, as a picture, you might want to think about this like a dollar with a circle cut out, and so what we're trying to do is get the area of this region that I have just shaded in. So it is probably obvious that what I want, the area is the area of a dollar and subtract off the area of a quarter. What I'm going to do is use the numbers that I have at my disposal. I'm going to use everything unrounded, 16.025 inches squared, and I'll subtract off 0.71630 inches squared. And I can conclude that my final answer here would be 15.3087 inches squared. I'm not ready to round to report my final answer because as I look at this, I remember that I only trust this answer to the first decimal place, whereas I trust this answer to the third decimal place. I have no business trusting anything that happens beyond this place. I don't trust anything beyond the first decimal place. That is the limitation. And so for my final answer, I should trust this only to 15.3 inches squared as the final answer for that. This is a reminder that if you're doing addition or subtraction, the limiting term is the term with the number the limiting term is the number with the least decimal places. And so when you report your final answer, the final answer should have the same number of decimal places as the limiting term. Here we had 1 decimal place, and so therefore here we have 1 decimal place.